is presumably on deck. Are you there, Ting?
Let me just unmute. Okay. Yeah, I'm here. Okay, let me try to share my screen. Okay, I have the screen. I think I need to do the share sound. And let me get rid of this guy and get to the presentation. Okay, where's my presentation? Oh, no, not this one. Okay, this is, all right. Slideshow. Okay, I hope you all see my screen. And the topic is OOE4 2.04. Okay, the authors I included Sean Chen, Brad Nelson, Chu-Chen Lee, and me, myself. I think it's kind of interesting that Sean is 18 years old, and I'm 81 years old, and Brad Nelson and Chu-Chen Lee were just in between. So I'm very glad to have all these people contributing to the to this project. Okay, I want a simple fourth in Java modeled after JE4614. And all fourth words, integer literals, string literals, and address literals should all be objects. All colon words should have linear object list, no branches, no loop in them. A true object-oriented fourth. So in this implementation, there are only two types of words, primitive words and colon words. Primitive words are the system words, which are called the primitive objects. All user-defined words are colon objects and or colon words. And I designed a single class called class code, which can construct all fourth words as objects. And all primitive objects are stored in a dictionary using their names as keys. So the dictionary, I mean, all the primitive words have their token, have their names as the tokens. And the colon objects are sequentially added to the dictionary. And all words are assigned a serial ID, which are the conventional fourth tokens. And all colon objects contain linear object lists, okay? So all the colon object has a list, and they have just a sequence of objects. And all colon objects are executed by this very simple inner interpreter. So you just go into a list and then execute, pull out each object of this list and execute this, this object. So you just continue this one for the whole list and done with it. Okay, and this is normally called nest in conventional for systems. So we have in Java, all programs are classes. Okay, so this one, the top class has the same name as the file where it came from. So this I call this file E-force204, and it has a top class is E-force204. And in this class, I defined a stack, a return stack, a dictionary, and the dictionary contains all the objects, including the primitive objects and the colon objects. And it also has several methods that it can execute depending upon situation. So the main, it has a default main method, which will always get executed. And I think this one, this should be an underscore, I mistyped. And I have a setup dictionary. That method sets up the primitives. And then the outer interpreter would go around and pick up a stream from the input device and interpret the character stream. And I have another class called fourth list, which manages the dictionary. And another class, the class code construct all objects. And here is a graphic representation of this class. Okay, the name is E-force204, and you have the stack, which is a list of integers, and the return stack, which is a list of integers again, but generally represented the routines that needs to be executed. And then we have a big dictionary. The primitive, first half of it is the primitive objects, which are boot up with the system. And then if you define any new words, which will tag down to this dictionary. And there are just a few types of objects. And the primitive objects and the colon objects. And inside the colon object, there are integer objects, there are string objects, and there are three types of control structure objects. You have if else then branch, which are called a branch object. And there are begin and until these loops. And then there's four next loops. So these are all objects. And in this class E-force204, the class are defined, and then the interpreter is not a big routine. It's a very very small routine. And then the class code, which defines all the primitive and colon objects. And here is a list of the beginning of the big primitive methods. So this is the entire program, okay, and which is implemented as a class. And then it has the several classes which do various different things. And so I show you there are different types of force objects. So we have two different main class of objects, primitive objects and colon objects. And in the colon objects, there are 6 different kind of objects: an integer and string objects, the control structures, has the branch object, loop objects, and cycles objects. And so here is a picture of all these objects. The class code, which defines everything. So it has these attributes. And many of the objects it creates uses only small number of attributes. For example, the primitive object, it has a name, and it has an optional immediate flag, and it has a method, okay? And all the colon objects has a name, and it has a PF field, which contains an object list. And all the colon objects are executed by this inner interpreter next, okay? So inside this object list, inside the object list, you generally have all the primitive objects and other colon objects, and then it also colon objects in the colon list can have the integer literal objects, array objects, string objects, branch object, loop objects, and cycle objects. And each of these objects are basically a colon object. But in the PF field, it has only one object. And this object does its own thing. But each of these colon objects are executed the next function. But it has only one object in this list, and this sub-object does its own thing. So for example, an integer object, it has a name, do_count, sorry about the type, and in the QF field, it has the value, and it just executes to .count when it is called out. So an array object is same as a variable object. It has a do_var. The name is do_var, and the method is the do_var method. And a variable has a single value in its QF field. An array object will have a sequence as many values as there need to be. And a string object, it has a doString, and in the literal field, it has the string value, okay? So in the branch object, you do the if-else thing, okay? So here, the branch object has 2 lists. This one is the true object list, and this one, PF1, has the false object list. So if it's true, then you execute the list in PF. If the stack is 0, then you execute the optional list in PF1. So this way I can encompass the alternative passes in a single object, and that makes a branch object inside the object list. So if it is a loop control object, then inside this loop object is a PF and PF1, two lists, the same as the branch. But this, of course, begin, begin again, begin until it has only one PF list. So this is the list that you will repeat. And if you have a begin while repeat, then after the begin, you execute the PF list, and after a while, you execute the object list in PF1. So this one takes care of the begin again, begin until, begin while repeat, these three different loop objects. And in the cycle object, you have the for next. So here you have three different alternate paths. So if in between if and the next, you have the PF. But if you have the for after, then next. So then the PF is between aft and then. And the PF2 is the portion after the then. So this one, you can do either for next loop or for after then next loop. So all the here, all these various things that you need to include in an object list are implement as lists themselves. Okay, so the object list is a linear object. Is a linear object list. It doesn't have loops or branch. And because all these branches and loops and cycles are all absorbed into single object lists. And so you have only linear list, and this list can be interpreted very conveniently by this very simple nest method. Okay. So this just go into the details of the object. The primitive object has a name. Each object has an ID, has a token. And the primitive object has an optional of immediate flag. And they all execute the method selected by the name. So this and the colon object has a name, has the sequential ID, and in the PF field, it has an object list. And it would use the next, not that, this should be nest method to execute this linear list. And for integers, like constants, and you have an object which will do execute do_com, and do_com would pick up the value, return the value in the QF field. And a string object would store the string value in the literal field. And, and this is used by the dot quote and the string quote for words. Okay. And for control structures, there are branches and loops in an object list. And there are 5 control structures with, that are colon object with alternate passes. Okay, so the if, else, then, you have if the stack, top of stack is true, then you execute the PF. If the top of stack is 0, then you execute the PF1. So the begin and again, you always repeat PF indefinitely. And the begin PF until, and you will repeat PF if the top of stack at this point is true. And you the begin while repeat loop, you would execute PF at the begin, and when the while test, if it's true, you execute the PF and then repeat the whole process until the while sees 0, then you will branch off. The for after, then next has potentially 3 different sublists, and you can just execute them depending upon the conditions. Okay, so this is the you know, in the E4 system, we only have these 5 different structures, 5 different control structures. So we only have to implement each and every one of them as objects. Okay, so here the object, we have a branch of object created by if, and the begin would create a loop object, and for would create a cycles object, and then depending upon the contents of these structures, you would construct the object with PF, PF1, and PF2 lists. And when you execute them, you just pick up the proper branches and execute them. So it's a very it's not a you know, every fourth designer knows how to construct these structures, and the only thing is that I have to turn everything, the PF and PF1 and PF2, they have to be linear lists, and they have to be stuffed into the branch and the loop and cycle structure objects. And the branch object having the ID and has a PF object list and PF1 object list, and it will execute branch branch method. Okay, and it's used in the if else then phrase of the branch structure. And the loops are it is created by the begin, and then compile the sublists. And the cycles is similar, but it is for the for next loop or for after, then, and the next loops. Okay, in this 204, one thing that I added is the Windows interface. And the I'm using the method in Java AWT class, this abstract Windows tool, or abstract Windows tools, I guess. And it is actually very easy to put up a Windows. And I only need 2 different and 2 different elements. Okay, you use the frame to create a container, a big window, And inside the frame, I put an input text area and output text area. The input text area will receive text input. You put anything into the input text area and hit return, and all the characters in the text area are sent to fourth interpreter. And anything generated by the fourth interpreter would be added to the output array, which get displayed. So this is a very simple window interface, but that's enough to run the OOE fourth. So I'm very happy with that. So this is the picture of the frame. The frame has two windows, and these are text areas. And the input window or the input text area, you can paste in a large number of text, and I just put in the whole text file into this window, and then hit return, and until all the text in this area gets interpreted, and then all the output put into this window. And this window can be very large, okay? So you can you can generate lots of text in this window. And then you can cut the text out and save them into text files. So in this, what I'm doing is I just avoided using the files in fourth. So fourth only handles input from this window and all put the output into this window. And it's done. And the fourth does not have to deal with the file structure or in the window. And if you get into files, window gets very complicated. So I'm only handling input from an input box and only put output in an output box. Very similar to a regular terminal. And so it doesn't take much to implement this interface, but it is sufficient for fourth to run very smoothly. And then this fourth in the main method, it has the outer interpreter. And the outer interpreter is called by key element when the return key is pressed to evaluate the text contained entered into the input box. And the parser is a Java method, which is called the next. So scanner in is the scanner class, which handles a text stream. And the next just parse out the next word. So this is a very nice service provided by Java, and I don't have to worry about the parser. You know, parser is a big word in eForth, and here it is there. I don't have to do anything. And in the interpreter, because object list in a coding object is always a linear object list. So a linear object list can be executed or evaluated very conveniently by this very simple inner interpreter. So you just go to a loop, fetch out each object in the object list, and execute the object. and you do everything for this PF for this object list in the PF attribute, and you're done. The linear object list can be terminated early by throwing an exception. So the object list usually are executed from the beginning to the end. But if you want to exit early, you can. And the exit, we use the exit object to terminate this, terminate the object list. And the mechanism is to call an exception. And the exception would catch by the catch phrase inside the nest. Colon object compile a linear object list in their PF fields. Linear list can be nested indefinitely to solve complicated problems. So this is we in for you use the if else then and begin until and for and nest loops, and you can string them together any way you want. But in for these objects are written out inside the colon definition. And here I just consolidate all the control structures into single object. And these objects, the linear object contain object which can be linear object, so they can be nested indefinitely, including all the control structures. And this way we can solve any problem you can solve with fourth, you can solve it with the OOE fourth. Okay, in conclusion, EF fourth 204 implement fourth words as true objects. And the EF fourth has only 400 some lines of source code. And it is the second smallest fourth after JE for 614, which has 379 lines. I was thinking that this E4 should be smaller than the JE4, but it's still a little bit bigger. But it is smallest Windows fourth ever, okay? And I just have to make some comments about Windows fourth. You know, for years I've documented FIG fourth, Poly fourth, F83, and FPC. And I gave up on Win32 fourth because it was too complicated. I don't know how Bill does it, okay? But when I tried to write the documentation for Win34, and I gave up because it is too complicated. For my own sanity, I started E4, okay? And the Windows just getting too complicated, and Win4 gets too complicated. I just couldn't understand the whole thing. And it unfortunately, Ye Jianxin, a friend in Taiwan, gave me F#. And the F# is E4 with a very simple Windows interface. And for years, I survived on it. But the window interface inside F# is still complicated. And I didn't completely understand it. but it's simple enough for me to use it to solve all the problems I encountered since. Windows might be complicated, but Windows interface should not. And E4204 is simple because it uses only text input and output. It just opens up two windows for input and output, and that's it. If you try to get into files, menus, and buttons, things quickly become orders of magnitude more complicated. And that's why I just couldn't handle regular Windows 4. And I'm very happy that E4 with a very simple interface allows me to throw up that window on the screen and start using it. Okay, here is the link to the current E4204. And I already called it outerInterpreter. Okay, so I think I put up this this link on the chat, so be sure to copy it and try to get to it. And if you have any question, please email me comments and suggestions. ChenHanSongDing@gmail.com. Okay, I think this is the presentation. I'll try to run some demo, and you guys can have questions while I prepare. Okay. Oh, let me see how to get it out of here. All right. Okay, I have to close this guy. Let me close this guy. Let me close this guy. Oh, let me see. Let me minimize this one. And okay, this is the Eclipse that I used to run Java. It'll take a little to load. Okay, this is the Bill's challenge. Okay, so here is some implementation to respond to Bill's challenge. And then let me see. Just be patient. Eclipse is kind of nice, you know. It gives you an IDE where you can try out, test all the Java programs, but it takes a while for load. Oh, in the meantime, I probably can show you. Oh, everything seems to be stuck. Okay, in the Java 4th. Okay, what I want to show you is this Java file. Okay, edit. All right, this is an entire file for the OOE for 2.04. So you can have the, this is the big class E for 204. And here is the setup dictionary. So the Chu-Chen Li actually use this one line of code to construct all the primitives, and where I took the hundreds of lines of code to do it. So I'm very happy that he find a better way to construct all the construct the entire dictionary. And in the dictionary there are immediate words. So here you just set the only those immediate words with the turn the immediate flag to true, and this implement all the immediate words. And then this the main method. And inside the main method, I set up the actually the window interface starts here. You put up a frame, and you put up a TextArea input, another TextArea output. And with this elements set up, you initialize these few elements, and you set up the font, and put up the set up the input box and output box, and set up big frame, and then you have it. Okay, and here is the Windows add window listener. So here you listen to the events inside this in the window, and you add a key listener so that you listen to the return key. When the user hit the return key, then it grab all text in the input text box and give it to the scanner to interpret. And then you call outerInterpreter to run through the all the words in the input box. And this is the outerInterpreter. The outerInterpreter looks up. You look up the next word, which are called idiom, and then try to evaluate this word. Okay, you try to find it in dictionary, and if you can find it in the dictionary, you would execute if it's not in compiling, or if it is an immediate word, then you execute it. And if it is not, if you are not if you are compiling, and you add the new object into the current object list, so this way you compile it. And if it is not a word in the dictionary, then you try to parse an integer, try to interpret it as an integer. If it is an integer, and if we are in the compiling mode, you add an integer literal object into the list. Okay, if you are not compiling, then you just push the integer on the stack. And if it is not a word, if it's not a number, then you throw an exception. Okay. So this is the outerInterpreter, and then Chu-Chen actually added this fourth list, which extend an array list. So it add all the tools to manage the dictionary. So you can find the head, you can find the tail, you can find anything between the head and the tail. And you can find a word in the dictionary. And I specifically asked him to search the dictionary in the reverse order. And that's how we implement our dictionary. So you search a dictionary, you always start from the newest object and search backwards. Okay. And then you can set the head, you can remove the head, you can remove the tail. And these are all the things that I have to do manually in the code when compiling new words into the dictionary. But he automate everything into the fourth list. So this really makes the whole thing much simpler than what I used to have. Okay, here is the constructor. And this is the class code with all the different fields. Looks rather complicated, but it is complicated. But because it is a one size fits all constructor. And this
Ting,
one.
I'm sorry to interrupt. Can you
Yes.
wrap it up? We're getting short on time.
I will. I think
Full schedule. Thank you.
Yeah. So this one load up. Okay. And what you do is push this key, push this run button. So it will only take 1 minute. So push this button and it will get the, okay, we got the two windows, right? And in this window, it has a word. So if I push this, and you get the word. And I usually use well, I usually cut the entire lessons file into this window and press return, and everything gets executed. But you guys have seen enough of it, so I would just stop here. And if there's any question, I would certainly like to entertain it. Okay, let me stop the sharing. All right. Okay, Kevin, you have it. Okay, Joe. You need to unmute.
Okay, well, maybe Joe, if you could just send chat messages and